Great. So this seems to be a very, very timely topic. We've all probably experienced the pain that David's talking about, and are all very keenly interested in reproducibility. Interestingly, we have sort of the same motivating quote from Max about why we're thinking about this. And so I want to talk about a system that we've been working on called Packrat that addresses some of the same sorts of issues, sort of works in some of the same themes. And I think David did a wonderful job talking about why we should all care about reproducibility. I think most people here probably subscribe to that. And I want you to think about two dimensions of reproducibility because one is across time. People oftentimes, in science, we want to make sure we can reproduce work years in the future, decades in the future. It's one of the principal benefits of working in an open source software ecosystem. But there's also across space. David addressed this quite a bit, to say, I want to move code between collaborators on a project, and we need to make sure we're in sync. Or I need to move code from my desktop where I'm developing it to the place where I'm putting it in production. So we want to make sure we can always reproduce things across time and across space. And I think R intrinsically does pretty well at this, but I think we can do significantly better. And as David pointed out, there's some holes in how things work now, and I think a lot of improvement is possible. So we think about the various dimensions of reproducibility. Because we do our data analysis with code, our computation is inherently reproducible. People who do data analysis by pointing and clicking or by using Excel spreadsheets that's impossible to see what they're actually doing and impossible to inspect them, have a problem that we don't have. So all the work we record in the script, and the computation is reproducible. Oops. Oh well. Output. We've heard a lot about, we've all been using a lot of these tools for a long time, but we have SWeave, we have Knitter. You can create reproducible output, and that's a wonderful step forward as well. But there's another dimension, which is configuration. So we can run our script and reproduce the output, but can we reproduce the configuration? Can we reproduce the versions of all the packages that we were using? And I think obviously you can do that, but it's with a lot of effort and bother. And so by and large, a lot of people don't do it. I think what happens, everyone's probably experienced it. I develop something today, 2 years later, I try to run it again, I update R, I get new versions of all the packages. The odds are probably pretty good, especially as time, I say 5 years, it's probably certainly not going to work. But even in several months later, you see this issue with scripts, with reports. So configurations, unless they're in some way stabilized, degrade. And there was a lot, many of you probably saw this, an epic thread on RDevel a few months ago about this topic, and it's sort of a proposal. Maybe we should freeze CRAN along with our releases, and that way sort of everyone would have a known target that they're shooting at. There was a very extensive discussion about it, and of course there is a simplicity to it that the end user doesn't need to do anything. They just say, I just know when R31 comes out, all those package versions are frozen and they're not going to change. But I think it's a problematic notion. You think about if we could solve, if CRAN could be frozen, we've got a very emerging, rich ecosystem of other places that you get packages from. You get packages from RForge, you get packages from GitHub, Bioconductor, other repositories, internally developed packages. And I think one of the things I'll talk about more in the next slide is, inevitably, it's great to say, oh, CRAN is frozen and it works, because it was frozen on a day and therefore everything works. But inevitably, you need one more bug fix, one more feature, one more compatibility problem to overcome. And so that frozen CRAN actually doesn't solve the problem, isn't what you need. So I think it doesn't really solve the whole problem to freeze CRAN. And the biggest thing, as I was just reinforcing, you don't get bug fixes. You don't get the vitality of CRAN, which is that things are constantly being improved, compatibility issues are constantly being addressed, package interactions are constantly being improved as well. And I think you sort of think about it, when new things go into CRAN, a number of things can happen. They can fix a bug, they can overcome a compatibility problem, or they can introduce bugs. And I think, by and large, bugs get happen and compatibilities get introduced. By and large, it's better if we have access to the latest code from package authors. And I think what happens is that if you don't, then people will find all sorts of workarounds, and you're sort of back to the same state that we were in. So I think freezing is definitely the answer. We have to figure out what to freeze, though. And I think freezing cran will solve a subset of the problem, introduce other problems. I think what we really need to think about is freezing projects. It's saying, I got a project working, I got a script running or a knitter document rendering, and I've sourced my packages from all over the place. I may have even gotten a package author might have even sent me a tarball and said, oh, here's a fixed version. And I've got that in there. I want to make sure that still runs. So projects need to be able to freeze arbitrary combinations of packages with a guarantee that they can use them in the future. And I think the good news is this is actually a solved problem. Many other environments deal with these issues, and this is by no means an exhaustive list. But there's basically most environments have some variation on a per project private library, some way to specify I want these versions of packages explicitly, and then the ability to say, given that specification, reconstruct the project so that it has all those packages. You have Ruby Bundler, NVM, Virtual Env, Python Virtual Env, and they vary in their approaches and they don't overlap exactly with each other, but it's sort of the same theme. So when we think about R, I think to David's point, R users do not typically self-identify as software developers. They are scientists or economists or data analysts or statisticians. And so I'd say the tolerance for additional workflow overhead is low. I mean, there's a system for Java called Maven, which is just, there's this unbelievable expansion of overhead of workflow. Java developers love that stuff, you know? and nobody thinks it's a problem. Like, it's beautiful, look at all the things, all the knobs that I have to turn, you know? But our developers, our users, don't want to do that. So I think what we want is, we want a system that has flexibility, underlying flexibility, but it can also be highly automated. So you can get the benefits of it by calling one function or two functions. Simple, easy to use, but also flexible. So I think, repeating it, we want those same kind of benefits, but we want it to be really straightforward. So today we want to talk about, and Kevin has been working on Packrat for the last few months, and wants to give you a demonstration of a possible solution to this problem that we've been working on called Packrat. And it's an R. Packrat is itself an R package, which has no dependencies. So keep it simple. And it is a dependency management system for R. Right now, you can get it on GitHub, but we're going to be submitting it to CRAN later this year, hopefully soon. And it does exactly what I was outlining. It creates a private package library for each project. So the lib path is updated so that all the packages that I install and use come from my local package library. And there's really two verbs. There's several operations, but there's two fundamental verbs in Packrat. One is Snapshot, which says both record the package versions I'm currently using and download the source code for all of them. So no matter where a package came from, I got it from GitHub, I installed it from GitHub master. Go get the source code for that. I got it from CRAN. It's this version. It's maybe I installed it 2 years ago. Go get the source code for it. So let's record the versions. Let's download the source code. And so now, at any time in the future, even without a connection to the internet, I can call Packrat restore, and it will reconstitute the packages that I was using at the time I called Snapshot in a private library for that project. So that's the basic concept, and Kevin's going to show us a little bit of how that works.
So I'm going to go through a sample workflow of how you might use Packrat to manage a project. I'm going to do it with Rstudio. We've got a lot of nice integration with Rstudio built in to use Packrat, but Packrat itself is just an R package, so you can use it regardless of the environment you work in. But let me start by just creating a simple project and using Packrat to manage it. So first thing we'll notice here is if I'm using Rstudio to go and create a project, now we have this new option, use Packrat with this project. So I'm going to create a new project, Rstudio is going to go, and Packrat's going to do some work behind the scenes to make sure we're ready to enter Packrat mode. So we're going to have our private library, we're going to be ready to start snapshotting things as the library changes. I'll just give it a simple name. So we see it's initializing the Packrat project. The first thing that every project needs is Packrat. So we get Packrat from GitHub, we install Packrat, Rstudio jumps us in, and now we're using a project in Packrat mode. So the main signal that we get from the IDE that we're using a Packrat project rather than a standard, or I guess vanilla style project, is in the packages pane. We now get this bit of extra information about Packrat here, and also the Packrat library, where we have our isolated local packages that we're using. So before I jump into a little bit of code, the things I want you to see here is we've got these two columns here, version and Packrat. Version is referring to the version in my library, in my private library, what I have installed. And the Packrat column is telling me what Packrat knows about. This is what I can restore if I need to rebuild this project at a later date. So suppose I have a very simple project where all I'm doing is loading string R. This is an implied dependency on the package string R. So I save that into an R file, I go here, and now I'm going to want to install that. So I just do the regular workflow, install.packages string R, it downloads it. That package is now installed in the library. And we also notice that Rstudio tells us, hey, I see you've installed string R. Do you want to add that to the Packrat log file? Do you want to snapshot it so that you can later restore it if you need it in the future? When you click this, it gives us an outline of the changes that we're going to see. Click snapshot, and notice that it's just making a call to functions in the Packrat library package. So Packrat is just doing something, and Rstudio is giving you some UI, so you have a better understanding of what it's trying to do. So now I want to show you a couple cool things. So we know this project has a dependency on string R because I have an R file using it. So what if I actually remove the package now? So this will delete it from the local library, not the user library. I'm not touching any of the other packages I've installed elsewhere, just in the private Packrat library. And so notice how the Packrat in here bumps in and says, hey, you've uninstalled string R, but I can clearly see that you're using it. Are you sure you don't want to put it back in? It asks me to update the library. I go ahead and do that. Packrat just reinstalls it for you. Notice that it builds it from source, the source callable tarballs that we got when we snapshotted. And so now we have restored the environment we had previously. Similarly, if I do the same thing after removing the dependency on string R, now it's telling me, hey, I know you're not using string R anymore. If you want to keep your private library clean, now you can get rid of that. And so once again, we click Update Packrat. Remember, this operation is a snapshot. We're updating our log file to say we no longer need string R. We do that, and now we're ready to go. And so, of course, this will still work if we have packages that require dependencies or packages from GitHub. So say I wanted to get the latest version of RCPP on GitHub. For those of you who are familiar with DevTools, we also package up install GitHub with Packrat just so we have a dependency-free mechanism for getting packages from GitHub. So we do this, it's going to download it. Once again, it's going to use the private library. It's going to do a whole bunch of work to compile it because I'm using a version of R from source. And also, when you install packages from GitHub, it has to build them anyways. Once again, we get that as well. And so notice that, this is a GitHub package. There's no guarantee that it's going to live there forever. Hopefully it will. But on the snapshot, we've pulled what we need from GitHub, so it's going to stay there over time. So we have this guarantee that even if the package disappears from GitHub, we still have it locally if we need it. Now, Now, the other thing I'll show off here is if we want, actually, so one of the things that's a little bit mechanical is this snapshotting every time you install a package. So one feature we have built in is this auto snapshot. So if you install a package, Packrat can usually say, you just installed that. I imagine you want to include that in the log file and save it over time. So here, this is just a way of setting a project option that says, do an automatic snapshot. And so that'll try and do an automatic snapshot when it's a non-destructive snapshot. So let's try installing string R once more. So it's going to go through the same steps of installing here from CRAN. And notice on the side here, it's just automatically snapshot. Packrat now knows about the package string R. You had it in your code, you downloaded it from CRAN, you probably want it in your log file, so we just do that for you. And the last bit I'll show you is, of course, we want to make sure that these environments we create for a project are shareable if we need to collaborate. Of course, we have version control systems if you want to work with Git or GitHub. So one way, if you're using GitHub, we don't push your private library up there, we push the sources. We can restore if we do that. Or we can also bundle the project. And so this collects all your code plus the package sources into a tarball that can be used to rebuild the same project. So I've just saved this, I've bundled it into something called bundle.tar.gz. And if I want to unbundle it now, so this is a tarball with just the source packages, no library. I'm going to put it on my desktop. So this unbundle command is going to unbundle it on my desktop, and notice how it goes directly and just restores the project library. We've got the package sources, we know how to rebuild them. So let's just do that. Let's regenerate the environment we needed to use our code to run the analysis, and we're ready to go. So just to prove that it's there, I'll go to my desktop. We've got my Packrat project unbundled here. And now we have the exact same environment that we had before. All right, so I'll end my demo there, and I'll do a quick recap of the commands that you'll use in the Packrat workflow. If I can convince Chrome to go full screen. Let's just go with this. All right, so the three main verbs, well, the two when you're working in a project, you have snapshot and restore. Snapshot updates the log file, grabs package sources, it gives you a state that you can rebuild your project from, and restore uses that snapshot state to restore the environment. So you or someone else can work the same set of R packages. Packrat's init does essentially those two steps to look at your project, figure out what you need, get the package sources, and install them. So it sets up the environment in one function call. So we saw this before, but a Packrat init on an empty project, we always need Packrat, so we'll grab that. When we snapshot, suppose we had a project dependent on reshape 2, it's going to grab reshape plus the dependencies, so we get those as snapshots from the CRAN current. We get those sources, and it updates our log file. If we restore, we can also download the binaries of those packages that we depend on. And similarly, like I showed before, we don't have to work with just CRAN. We can also use GitHub here. So if we install RCPP from GitHub, we take a snapshot, it updates it for us, and now we have this GitHub version of RCPP that persists over time with our project. And finally, bundling and unbundling is a nice way of sharing this environment. If you just need to send a tarball and someone just wants to call unbundle from their R session to set it back up, it's just a two-step process to take your project, bundle it up, send it to someone else, and restore that environment. The other thing is we have Packrat designed to work nicely with version control. So whenever we commit, say, a GitHub file, we store everything we need to know about where that package lives in the GitHub tree or repository. So we know exactly which commit we need to look at to get that package. So as long as that GitHub repository persists over time, then we can get that same package. But of course, if it doesn't, we have the sources locally, so we're still safe. And so the overview of just what's going on is you have your lock file in your private project library. Use Snapshot to update the lock file, get the state of your library. Use Restore to apply the state in that lock file to your library. And then Packrat makes sure that all these calls to your regular workflow functions for updating your library, install out packages, update out packages, or packages to pull it from your private library, whether you call it with library or reshape, it'll come from that private library. So we really want Packrat to be used to create these isolated, portable, reproducible environments for our projects. The idea is that they can live over time and be shareable with other people. Because we capture the source package tarballs, we can rebuild those quite easily. And what is quite nice is it requires no changes to CRAN. If for some reason you need an archived version on CRAN, you can install that yourself. Packrat will track that. It'll keep that in your project. It might encourage you to update, and you probably should if the package maintainer is introducing updates. But if for some reason there's a breaking change in the API that you just can't handle in your project, you still have the same environment that you know works, and you can save that with your analysis or project. And so, as we saw, it's quite easy to snapshot, restore, bundle, and unbundle. We try and make it unobtrusive and easy as possible to use in the workflows you already have. And especially the integration with Rstudio makes it even easier to use Packrat because there's a lot of complicated ideas and machinery. But we want to make sure as much of that as possible is automated so you don't have to deal with it. And so, while Packrat only tracks our package dependencies, I could see it easily being integrated with other environment reproducing projects like Docker for keeping these environments, both our packages and system requirements, otherwise environment or computer environment requirements altogether. So if you want to learn more, we have a Git tutorial on the Packrat website. It's very nicely laid out. We have a walkthrough. It's a good way to get started. If you want to look at the Packrat source, everything is available on GitHub. You can go pour through the 663 commits that have been placed in there. And we encourage you to play around with the version through DevTools install GitHub, and we will be putting it on CRAN soon as well. All right, thank you very much.
Does it work across all operating systems?
Does it work across all operating systems? Yes. So as long as you have the build environment, especially for compiled packages, as long as you can build those packages from source, it doesn't matter what operating system you're on. We bundle the package sources. CRAN ensures that those are buildable on Windows, Mac, Linux, Solaris, if you're lucky. So it's definitely usable across all operating systems.
I got a couple of questions. You didn't show any examples where, you know, when you loaded one package that it actually got all the dependencies about other packages. I assume that works, and if so, does it go to all the way to the suggest level?
It doesn't go to suggest because you'll quickly find out, as David was pointing out, you know, that example, there were 30 packages. If you did suggest, it would probably be 300 or 400 packages. So it does not, it does do, like reshape 2 was the dependency that we had, and then that got plier. RCP, and so it does do depends. It does not do suggest because it would explode.
Okay. Then the other question I have is that I could be saving my packages and then when there's version 20 of R, all of a sudden these packages don't work. So is it saving the R version as well?
It saves the R version in the Packrat lock file, and so there are other ways to try to run different versions of R. We don't address that in Packrat, but you can run old versions of R, obviously. So we do save the version, and it's something we'd like to do in RStudio would be like we look at the version and then we automatically run the correct version of R, that corresponds to the log file.
Yeah, that's definitely going to happen.
And I think that if you have more questions, the RStudio folks are very accessible outside in the lobby during the breaks.